streaming. Okay, looks like it's active. Video capture device, desktop audio. Okay, it looks like it's active. Okay, so it's working. Video capture device. Stop sharing. Okay, so couple of things we did so we had like a test. Okay, so we had like a test this this Saturday, and I got some feedbacks, but I really wanted like everyone because we only had like so let's see who's online here. I think she showed up. So I haven't graded, but I kind of looked over. It looks like most people did pretty well on the on this test. So that's okay. I don't mind. You know, like if everyone gets 190, so that's good. Um, and it's also like the first time I'm trying it, so I didn't really make the test super hard. And the test was password protected. The reason is that was password protected because everyone can start the test at different times. And I noticed like one person started like at 2:40. For some reasons, actually, I added a window because someone mentioned that she couldn't register. So I just add that window, but normally I will make it just 1 hour window so that you don't start a little bit later than everyone else. Okay, then and like one of the comments said that maybe I can post the test earlier. Um, I kind of read the comments a little bit because but so I didn't read it like so I just read it like right before the class, and there are like nine submissions. So like one of them said that maybe I can post the test earlier, but the problem is that when I look at everyone the time that everyone is registering, they all register at like Saturday right before the test. So I'm not sure if that's gonna help because people are probably just gonna procrastinate. I know it's 3 days before the test. I'm not sure how that works because the school, if they're paying for it, then I guess the school is gonna pay extras, right? Yeah, but I think there is like a chance that there is a chance that there's a chance that oh yeah, so if you want the URL, it's actually you can actually see it from the lectures, and the live stream is actually right there. I posted this beforehand. Let's try to share it. Copy link. So I'm just gonna repaste the link here, but you can actually see it from from the lectures in Blackboard. And I also have the OneNote there in class notes. Okay, let me see. Am I sharing? Let's exit full screen. Cancel. Okay, let me just switch over to the scene. Yeah, so it's actually in the live stream here. Okay, so today we will be talking about so the first thing that today we'll be talking about is the so it's 4.6, and I'm planning to just go over chapter 27 first. So let's go over chapter 27 as well as exception, and we'll cover a little bit of chapter 12 as well because last week we kind of went through quickly. Um, and I sent email reminding that everyone before the class, I want you to go over chapter 11 and chapter 12 on your own, so that you can have some knowledge before coming to the class. This way we can like verify your knowledge and try to see if you can apply the knowledge during the class. Wait. And I have too many windows opened. Okay, I lost everyone. It's so weird. Where's Zoom? Okay, what the heck is wrong with this thing? Okay, where's everyone now? Just lost everyone. Maybe it's this one. Okay, here we go. Okay, anyway, so today we'll be going over this ATM test case, understanding the requirements, then also maybe chapter 12. The reason I want to like rush into this because I'm not sure how everyone understands it. It may take some time for you to understand it because I'm sure you can do it without using OOP. That will not be a problem to everyone else here. And we have like a test on Saturday. So if possible, like if we finish everything beforehand, we can practice the test, like actual test two, right before the test two. And this one will be more of open everything. So this one again, I think it's not going to be 2 to 3 hours. I'll give you 6 hours. So in other words, it's not going to be on ProctorU because with ProctorU, it's very difficult for you to connect to the instructor or to the TA. And so I decided to make this more of a take-home exam. But I'll be connecting to Zoom as well as I'll be logging into Teams as well, so that if you have questions, you can contact me, share your desktop, and then we can talk about it. The goal of this test is also for you to learn about the OOP process. I know it may take a lot more time than 2 3 weeks, but but and also especially it's also online. It's going to be difficult for everyone to process it online. So I think it would be better if it's take home test or project. But I'm giving you about 6 hours limit. So it's going to be between from the time we start the class at 1 o'clock until 7 o'clock. So 7 o'clock will be the final submission time. And I'll be connecting to Zoom, so everyone will have to be connected to Zoom in the beginning. Then if you want to disconnect, that's fine with me. And um, so it's possible that I can create like a couple of different scenarios, just in case that you share the work, because I don't want to um, handle too much on dishonesty, and I'm hoping that you're not gonna be too dishonest. So in the end, if I see like two solutions that are exactly identical, names, class names, logic, everything is identical, then both people will get 0. And I'm very serious about this, because in coding, there's no way that you two can have exactly the same codes. Even like even the order, the classes, the class names, everything is the same. There's no way. There may be some differences, um, but if you're actually starting with a different design, then both classes, both of your codes are going to be different. So questions? Yeah. So I'll give you. So hopefully we can finish everything by in 2 weeks. I have a few practice questions, but the problem is that they're more suitable for test, like a face-to-face. Yeah, they're more suitable for to a face-to-face test. Um, I have those questions. You can practice on those as well. But the one that I'll be creating is going to be slightly different. The format is going to be slightly different, because I really wanted to start from the designs rather than telling you this is my design and I want you to follow it. But I want you to like come up with your own design based on the paragraph, like the description, and then create your classes and all the stuff. Questions?
So the questions are going to be the way which you give in the assignments, right?
Which ones?
Like the previous assignment which you gave for OOP, describing what has to be done, like how many constructors has to be created,
No, 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 no. The
not
test
like that.
is the test is going to be a little bit different, because if I ask you like that, then everyone will have the same codes, and how do I know
Hmm.
that you didn't share the codes?
All right.
So the thing is that I wanted to like start from designs, start from requirements. The one that I gave you, the homework assignment, they're mostly starting from like after the design. I give you a design and you write the codes. But if I were to ask you to come up with your own design, based
Mhm.
on the requirements, so the requirements most likely will have like about 3 classes, right? I'll give you about 3 classes and maybe one sorry one composition, maybe like one composition, like interfaces abstract class, and then a couple of our others. So probably like four different classes. Just treat this as like a project, but you're under like a time limit.
Okay.
And of course you're free to discuss with each other like what the heck am I writing in my as my requirements. You're free to discuss with each other, but you're not allowed to share the codes. If you do share the codes or even your design, then you're gonna have the same codes, and that's gonna be you're gonna be like um, penalized, because I don't see any like novelty in your codes. Um, but the goal is to actually just kickstart on OOP. I know like the courses that you're taking, I think Java didn't focus too much on OOP designs. Uh, and then SAND they took that out. So and then I don't think that there's any courses that will. But I think it's very good for you to understand how you can relate from real life case to codes. It's basically like you have the understanding of the problem, then how do you solve the problem by going over the SDLC, software development lifecycle. Um,
Professor, can we have an practice assignment this week, like for the design, so that we get an idea, like what you will expect, and we don't stumble into so many questions during the exam and
you want
waste.
so
Yeah.
you're asking more work.
Um.
I guess with you at home, actually right now I'm at school because uh yeah, but I'm not allowed to be at school, but I don't think there's
Yeah.
anyone. Yeah,
I hope you're safe
yeah.
because SSCB
Actually, I
is
forgot to
the
bring
one.
my. I have like a couple of N95 face masks. But hopefully, yeah. But just to record this one, because I have like everything set up at my office, so it makes it easier to record.
Mhm.
Um, Yeah, I can look up like what are the past questions I gave you. In fact, some of them I might have some design questions, and you can think about the design. You don't have to write the codes, because the most important part is the design. If your design is good, then your codes are going to be okay, like based on what I'm seeing from your coding, right? But if your designs are bad, then your codes are obviously are not going to be good, and you're probably not going to satisfy the requirements. So designs always comes first. That's the most fundamental. So you may spend so generally like generally I think it's like it's about your so let's put it this way, right? If you spend like little time in the design, right? Then you're going to spend some time in construction, right? I think they have a chart, but I can just estimate it. Let me just actually, you know what? Let me just go to my other desktop projector. Okay, okay. Let's see how does this one work. My mouse. Uh, okay, so all the notes will be uploaded. What the heck is it? Yeah. So this is one note. I think I can get this one working. Yeah. Okay. Why does it? Why did it just crash? I don't know why this just crash. So weird. Okay, maybe I shouldn't maximize it. Let's try. Is it this font? Draw. Here we go. Let's try this again. Okay, that's good. Okay, I need a keyboard just to undo it. Okay. Okay, so basically, the more you design, right? So you base. Well, actually, let's start from beginning. So you have requirements. Okay, then you have designs. Then you have constructions. So this is the first five tests I mean, four phases of SDLC, right? From a waterfall model, right? So this is like a standard SDLC, right? So the first thing is the requirements. So let's say we have all the requirements, right? In this requirements, you have to have a few things here, right? As you know, like in the requirements, you have to do analysis, right? And then you have to do uh yeah S. Okay, then you have to do design as well here. Okay, then under designs, it's basically going to be your OOP designs, right? Okay, then constructions are just going to be coding, right? And then testing is just going to be like debugging. Okay. So in this case, right, right, if you spend less time doing this part, so let's say you spend like a third, let's say in all of your codes you spend like where's eraser? Plus pen highlighter. I don't even know. Oh, here. Yeah. So if you spend, let's say you spend like a very little time here. Let's say you spend like 10% of your time, right? So let's say you spend um, like 10 minutes, right? Then you spend then here you're gonna spend a lot of time here, right? So let's say you spend like 90% time here, right? Then of course you spend less time designing, which means that your design are probably just going to be bad. And then you spend some time doing the coding, right? You spend a lot of time doing coding. Then 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 in the testing part, you will have to spend a lot more time. The reason is that this is going to increase the timing. The reason is that your codes are not going to be fully designed, and it will have some issues with your uh, uh, yeah, it will have some issues here. Uh, but the idea, right now, I wanted to focus on the design first. So we're gonna focus on design and requirements analysis. What the heck is wrong with this thing? Stroke eraser. Oh, I have to click on it. Okay. So we have to spend more time designing. So we're gonna spend more time here, right? And then less time here, right? Less time. And therefore you're gonna decrease the amount of time testing. The reason is that once you have a good design, your codes are gonna be good. Then you don't have to spend so much time testing it. So this will actually improve your codes. So that's where today lesson will be about. I'm not sure how to use this. Maybe I add it here. Home. Insert. Draw view. Draw. Maybe I do this one. No? How do I do a next page? I have to right mouse click. No, I can't. Oh, here, page. Okay. I'm not going to title it. Maybe later on. Okay. Is it control? Yeah. Let me just put this on the. Okay, so this one is 324. Okay, it's really hard. Okay, let me just switch over. Okay, here we go. Oh crap. Okay. Um. So we're going to go over chapter 27. You can find everything on the you can find this book on Blackboard. So you can find this book on Blackboard. So to find on Blackboard, it's on the home page and all the way at the bottom. This one. So you download the PDF or read the PDF, and you can read it. And also the test is available as well. You can go over the test. So I made it into one page. Okay, so you can go over this textbook. There are 44 pages. Uh, okay, so let me explain. Let me explain this problem. So this chapter is about the ATM machine, and the idea is to like to build an ATM machine, right? So in general, you have the requirements. So initial requirements, we have some requirements. So so you have a screen, display a message, right? Then you also have a keypad that receives input. So this is going to be input, and this is going to be the output. Then you have a cash dispenser. And then you have a deposit, right? So deposit. Okay, so that's the whole thing about this these requirements. We're basically going to build it on the screen. Then we have a key. So then you have a keypad and a cash dispenser. Okay, let me just see if I can just do it this way, right? Can I copy it? No. No, actually, no, it's this one. Okay, so this is where it said copy, hand tool, select tool. Edit, copy. I'm not sure if that's gonna work. Nope. I don't even know. Let me just do it this way. Okay, so this is our cash dispenser. We can paste it here. Okay, here we go. Okay, so this is what it looks like. How do I move this thing? It's so weird. Home. Can I even move this? Can't even move it. Oh, here we go. Okay, so this is an example of our screen. We have like okay, so here's an example of our screen. We have so we have like this the yeah, we have our account number, right? Then you enter the PIN number here. So in this case, well, we're not going to create like this kind of interface in here, but the goal is to try to simulate an ATM machine. So instead of having this kind of interface, we are going to do it more like a console application. So in here you have take the cash here. So this is a cash dispenser, deposit envelope. This is more of number 4. So this is a screen. Then so normally you will put your debit card into an ATM machine. In turn, it will look up the information based from your magnetic strip and authenticate you to the server somewhere. So your magnetic strip is going to have your account number, right? But since we don't have that, we're going to just type in the account number here. Okay, so initially the screen would display a message. So if you look at the screen, right, it will display a welcome message, right? So initially it will display a welcome message, then the user enters the 5 digit, right? So this is what it looks like. So welcome message, 5 digit, and then finally the PIN number. So that's going to be more of an authentication. So this is our authentication process. Okay, let me just get rid of this thing. So this will be going over to here. Okay, next we're gonna have we're gonna have another one. Uh, Sorry, just move this one over. Okay, so we're gonna have another one here. So in this case, this is more of like a deposit. Okay, here we go. Let me just move it here. Okay, so we have a deposit, right? So the screen displays a menu, right? So there's more requirements. So screen, hold on, let me just, okay, screen displays menu, just like this, right? Then you have a menu selection, 1, 2, 3, 4. Yes. Hold on. Yeah. So basically, you have one for viewing my balance, right? The other one for withdrawing cash, the other one for deposit funds, and then finally you have an exit. So that's gonna be you're gonna enter like 1, 2, 3, right? So you're gonna enter like 1, 2, or 3 for all these requirements. So we have like a few requirements. We have like a view, then we have withdraw, uh, withdraw, and then you have third one is deposit, and then fourth one will be exit, right? So we have a few things, and I think I gave you like an assignment on this, but it's a little bit different because now we have a screen, we have a keypad, right? We have this thing, right? Whatever it's called cash dispenser, right? So these are all the stuff that we're introducing. So all of them are going to be individual classes, right? So it's going to be a little bit different than what I asked you to do before. But we're just adding a couple of more, a few classes here, and then try to connect it together into a working application. Okay, then next we have like so let me just do this one again. Okay, so next we have like this, which is essentially like a withdrawal menu. So now you have to figure out how to get the withdrawal menu. Hold on. Yeah, so you have these different options, right? So first, this is actually withdrawal requirements. So withdrawal requirements, you have like you have the first thing that's gonna be like menu selection of amount. The second one will be oh yeah, so when you actually enter the amount, right? This one since it's the amount, right? So you have to like validate against your balance. So you have to validate against your balance. Okay, then the third thing, right? Wait, that's one, two. So menu selection. Yeah. So enters. Oh, so actually, you know what? We're missing one step. Sorry about that. So this one is yeah. So we're missing one step. One step is gonna be input selection. So in yeah, number. Then we're validate against balance. This means that if you don't have enough money to withdraw your the amount, then it's gonna exit or it's gonna ask you to re-enter again. Then you also have to do like validate against the cash dispenser, right? The cash you obviously cannot withdraw money more than the cash dispenser. Like cash dispenser only has a fixed amount of cash, and you can only withdraw like you can only withdraw like that under that amount. Otherwise, it's not going to allow you to withdraw. Then if these two are satisfied, right? Yes. Then proceed to withdraw, right? Proceed to withdraw. Proceed to withdraw, and then also display a message. So 5 and 6. Uh, Actually, my handwriting is getting bad. DRAW. Okay. Okay, then the next thing is that we can do the deposit requirements. So deposit, you have the first thing is to display some message, right? So this is obviously going to be like prompting, right? Prompt, right? The second one will be so enter amount, enter enter, enter amount, and of course you have to determine it has to be greater than 0. Then the third step is to wait okay, then this one this was, I think it's some validations, right? Validations, and of course all of them has cancel, right? So you have to do some kind of check here, some kind of validations here. Then number 4 is going to be display a message that tells the user to insert a, so display message. So like insert envelope. Then fifth one is going to be if the deposit slot receives an envelope. So this basically just received, then you deposit, right? So basically this is going to be adding your amount to adding the amount to your balance. Okay, maybe I add one more page here. So so the view requirements just so if you look at we have a view requirements, right? So this one just pull amount from balance, right? And then display, right? Balance on screen. Okay, so the first thing, so let me just go back and let me just type this up. So first thing is that we talk about SDLC, and today we will be focusing on requirements and designs. So requirements include analysis and requirements design. Then Then we're going to move on to designs, talking about how OOP works. So the first job is to look at the requirements first. The second one, this is the second page, is about like top overview, right? And then this one will be more of menu selection. What the heck? Why is it not showing me anything? Wait. Okay, let me try this again. Menu selection. Okay. I can't even type. I think I have a typo. Okay. So weird. Okay. And then this one will be view. And then we also have withdraw. And this part will be deposit. Okay, so this is all the requirements that we have. But if you try to break down, right, we have we still need like a few things. What is this thing? What is this? What is the screen? What is a keypad? What is a dispenser? And what is a and how do you deposit? So if you break it down, you see like how this is done. I think in chapter 12 there's an assignment on this because we are going to use the 4 principles of OOP, right? So again, let me just remind you on the 4 principles of OOP plus page. Okay, so this is the OOP principles. Okay, so the first thing is that, oh crap, wait, so weird, man, how do I get rid of this? Why is this? Okay, hold on. I can't delete a section. Why is it suddenly hate this stuff? Maybe I click on this and then this. How do I oh, maybe I can just expand it here. No. Okay, why do I have a section? Can I just delete it? Don't delete. Uh, Navigation panes. Okay, so show only pages. Okay, here we go. Okay, so let's add up OOP principles. And here we wanted to write down all the 4 principles of OOP. So what is the first principle? So now it's your turn.
Encapsulation.
So encapsulation, what is it? What does it mean?
Information hiding.
So encapsulation, right? You're
Data
basically
hiding.
you're hiding any members, and by hiding members, I mean I really mean like you can hide both the data. So you're hiding members. I'm not going to say just information because encapsulation can also refer to hiding the methods as well, because some of the methods you don't want to expose it too much. Like for example, if you're trying to delete a record, you don't want that method to expose it outside of the class. So you have to like figure out which methods, which data you want to hide. So hiding data and operations. So basically, what this means in C# is what? So which C# syntax or keywords allow encapsulation?
Private.
Private, right? So private. Now, what's the second principle? Anyone know?
Inheritance.
What?
Inheritance. Inheritance.
Inherit. So what does that mean? And why do we need inheritance?
To reduce redundant code.
Hmm?
To reduce repeated code. So that
So the reason could be
reusability.
yeah, reusability, right? So what exactly is inheritance? Use a different color. So let's write this one. So what exactly does inheritance mean? Or you can give me an example.
Calling one class from another or accessing one class from another.
What? Access another class from another?
Yeah, from the derived class to the base class.
Yeah, but what does it
So
mean by
that way.
derived and base? Because you know, like to access one class from another, you can simply just call a class. It doesn't have to. You don't really have to use inheritance.
Extend the class from another.
Yeah, but what does it mean by extended, right? You talk about like extended. Oh, keep on forgetting the
So we use the common features in the base class and the additional features in the derived class.
Yeah, so that's also to do with reusability. So reuse features. But
We can make
yeah, go ahead.
we can make modifications or changes to the properties or methods or data present in the base class and the derived class, and then reuse it that way. So we use inheritance.
Okay. Let me give you an example, right? And tell me if I'm getting it right. Actually, you know what? Let me just pull up Wikipedia, because I think it's one of the common mistakes that people make, and I don't remember the term. Look for this. Oh, gosh. Yeah, they have a few of them, but I'm looking for a specific one. No, it's kind of hard to remember. Okay, it's kind of hard to say this. Okay. Okay, so let's say one bad example will be let me just try to add another pen. Wait, can you click on that one? Actually, let me just get rid of this one. Color red. Okay, so one of the examples that you have, right? You have like a class, and another class extend this one, another class can extend this one, right? So to make it easier, right, we're gonna like have this one doing a lot of different calculations. So this class we're gonna fetch let's say user, right, for example, and then let's say this one purchase, right, item, right. Then we also have this one uh, so fetch user, purchase item, then we decide to add more stuff like display web page. So let's say display web. And then let me think of another example. And then we can have another one which basically let's say we do input as well. Okay, so basically as you can see in all this stuff, yeah, this doesn't have cursor. Let me just use a mouse. This one. Okay, so in all of the stuff, right? You see like in all the stuff you have like four different functions, right? But they are kind of unrelated. Like one is just getting a user. The other one you want to buy an item, right? Item has something to do with the user. Then you want to display some web page. Then you also do like input. So they have four different unrelated functions, and then we have a few different classes. Let's say this class let's say it's a user class. Let's say it's not user class. Yeah, order class, right? Actually, order class. Um, so we can have like let's say this one will be we have let's say this is like order and user, right? Order, and then you have a user here, right? So we have like two different unrelated classes, right? These are actually unrelated, and you decide to put an inheritance just because you wanna like reuse some of the features. But as you know, like if you're doing the order class, you don't want to like just display web, because that doesn't make any sense. So you're gonna tell that you're gonna ignore using this one in the order class. Likewise, for the user, right, it doesn't really make any sense to fetch another user from this user unless you want to look for in the friend series. And also, like it doesn't really make any sense to input the data directly in the user class, because this class should only have the data model, right? You should only look at the data model. When you input, it's the term is kind of vague, but you decide to write do a read line instead, right? So in this case, you have a user class. Inside the user class, you are allowing people to enter some information in the user class using a reline. But the problem is that this user class can only be used in the console application. It cannot be used on the web, whereas the web use a form field, right? And then you have display web. What about display web, right? Maybe you want like another one, right? Called like let's say a web controller, right? That makes perfect sense that you want to display a web page, but it doesn't make any sense to fetch a user from a web controller. So by reusing, it's kind of a vague term about inheritance, because you don't need to use inheritance for reusability, right? Does everyone understand or no? Hello?
Yes, Professor.
Yeah, do you understand why this example, like what am I trying to pull at? Okay, let me see any chats. 25th. Okay. Does everyone understand the example? Okay, so if you're talking about inheritance being reusability, how about composition? Then we have something called composition. Does anyone remember what does it mean by object composition? What does it mean by composition? Who's gonna talk or who's gonna chat? Don't make me unmute everyone. Anyone?
Is it like referencing other class objects for creating objects using the other class?
Yeah, so you're basically just taking one class and then instantiate as an object and then use it in another object or
Right.
class. Okay, but so why would you use composition over inheritance? What does it mean by inheritance? Because if you talk about reusability, doesn't composition doesn't composition do the same thing? Because you cannot you're doing composition when you try to reference like for example, if I write a class here, right? So if I write class, right? Let's say order, right? And then let's say this whose order is it, right? So we're gonna say private user, let's say underscore user, right? So this user, right, is going to be a composition. So this is going to be a composition, right? Composition. But what you don't want is that you don't want to write like this. Order. Then you decided to that okay, I want some stuff from user, so I'm just going to do it this way. You don't want to do it this way. Why not? So why don't you want to do it this way?
maybe we will have to implement everything in the user class, and if it is
Doesn't
not
matter.
necessary.
It doesn't matter. Uh, that's not the reason I'm looking for why. Why don't you want to use order extends user? Uh, so by doing the order extending the user, right? You can actually have yeah. So by doing the order extending the user, right? You can actually have some features from the user. Let's say user name in the order, but that's actually not what I'm looking for. So one of the easiest way to I don't know what's this thing. Let's see how do I get rid of this thing. Okay, this is a keyboard. Do it on screen keyboard. Close. Okay. Uh. Okay. Okay. So one of the things about the inheritance is that it can it's actually what it means is the is. Okay, so let me ask you this. If you try to read this, right, using the synonym, right, is, right, so you read is a user an order, or actually the other way, is the order a user? So if you try to read it, is an order a user? Yes or no?
No.
So if you say no, then this is a very bad idea about like inheritance. So if you cannot make up the sentence, an order is a user, right? An order is a user. If you cannot make up the sentence, then that's a very bad example, right? So that's why there's a difference between using composition and inheritance. Inheritance must have the keyword is, right? If you can't make the sentence, then it's you're not using it correctly, and that's why usually we will do it this way, right? So this user owns the order, right? This user places an order. And they both are unrelated, right? These two are unrelated, but what this order can get is a username, right? An email, right? So you can get all the information directly from the order based on from this object, this object. Okay, so in general, the inheritance will refer to is, the is keyword. So it's gonna be is. So basically, if you cannot form the sentence, what's going on here? Escape. Okay. So if you cannot form the sentence is, right, then don't use it, right? Uh, so this is what it means. You have to be able to form this sentence is. So an example could be a vehicle, right, and a car, right? Car extends, or car is a vehicle, right? Car is inherited from a vehicle, or car derives from a vehicle, right? Those are inheritance. So we have a few things. One is extends, right? So you have extend is inherited from. Then you have derives, right, from. Any questions on the inheritance? I don't want you to get confused between inheritance versus composition. So sometimes you may want to use composition over inheritance. especially with composition, you can have as many objects as possible in a class, whereas a class can only have one inheritance. But in C++, you can have more than one inheritance. But Java forces to have only one superclass. That's where the C# borrows it from. For a good reason. Okay, so what's the third principle?
Polymorphism.
We're going to talk about so which before that one?
Abstraction.
Abstraction, right? Yeah, polymorphism is related to abstraction, but that's why we have to leave it later. So what does it mean by abstraction?
Hiding.
Huh?
Data hiding.
Data hiding is encapsulation. Anyone know?
Hiding the implementation.
Hiding implementation. That's not quite right. Normally, if you create a method, right, your implementation is going to be hidden no matter what, right? When you try to compile to DLL, then no one can see your codes. But what they can see is your method header. So the only thing that they can see is your interface, but not your implementation. So it's not quite right.
It's like allowing the user to see only one part of the code which we want.
See
making
one
only
yeah,
making whatever we want as visible.
Make whatever. Yeah, so that means, I guess that means more of like a purpose, right? The goal. So the goal is to goal is gonna be passing passing what is it? Passing the contracts, right? I call contracts. Contracts will also be like the headers, interfaces, signatures, anything that you have a contract with an object. But abstraction would just be why does it keep on moving? Is it this button? Oh, where's my mouse? That's weird. Okay, so abstraction. So abstraction would just be that we're not actually we're looking at something that has so we're basically looking at the contracts, right? And then maybe there are some other instances, right? Other classes that could use the same kind of contracts with other systems, and then those are going to be your different implementations. Yeah. So this will allow people to extend your class, your designs by adding their own features. So this can allow like customizations of different features. Because as long as they have the same contracts, right? It means that the class with different implementation will still be compatible to another class. Now let's look at a polymorphism, right? The fourth step is polymorphism. That's in chapter 12. So poly means multiple, and morph means changing. So what does it mean by polymorphism? Okay, so polymorphism is kind of related to abstraction. Like you basically need to figure out which object, actually it's also related to inheritance, right? You basically need to understand which object you need, right? And if you actually go on the higher level, right, all the sub levels can also be connected, can also be used here. So the goal is to identify the most um, general class for you. So once you have identified the most general class, then you're gonna use that class as part of your codes. So one example would be like if you're only interested in printing the name of a person, right? And you have a person to employee, person to faculty, person to student, right? uh, then you don't have then it's not a good idea to just pass the student to that function just because you need to get the student's name, right? Instead, it's probably a better idea to go even higher level. So if you get if you pass a person instead of a student, then this the class that you can pass into the your method can be any other methods, any other classes such as an employee class or let's say staff class or admin class. So it doesn't have to be like just student class. So that's what we mean by generalization. So generalization will be an important concept when you try to look at your code and class designs. Generalization is actually another term for inheritance as well. Okay. Any questions?
No, Professor.
No? Okay, so let's look at our designs. Okay, so the book start off with talking about, so this is composition keyboard. Man, I can't type. Okay. Okay, so now let's look at something else. Okay, so if you look at the requirements, right? We have actually we have the three stages when you do I think it's menu selection. So in general the book actually mentioned about like using uh having a use case diagram, right? So you have a person, right? Let me just do it this way. You have a person, right? And then they can be connected to different things. So this is an example of a use case diagram. So that will be part of this diagram will be part of the design of your requirements, understanding how requirements work, and you start off with the designs. What else? Where's my oh yeah. Okay, so the book started with use case diagrams. Then they talk about class diagrams, which you probably wanted. You may want to consider using a class. Actually, I want you to use class diagrams. This is all like designs. This is the use case diagrams is requirements. Then we have class diagrams. They have state machine diagrams. So state machine. This one I don't really use it that much. But if you need to like understand the different states, you may want to consider using a state machine diagrams. Then you have the activity diagram. This gives you scenario-based understanding. Actually, yeah. So this gives you more of a like pseudocodes actually. Sorry. So this is pseudocodes. Let me just not use the numbering because that's not how it works. Okay. Okay, then we have I don't know what's communication diagram. I'll just skip that one. Okay, so then we also have in this part we have something called sequence diagrams. Okay, and then let's put a line here, and like this rainbow color. So this part, the first two diagrams are more of a requirements. The latter three are more for designs. So sequence diagrams are more like use case, like different. So use case are like you draw a picture of a person and then try to determine like what are the different use cases. Sequence is a specific sequence for a use case. Class diagrams, you can do that in Visual Studio. Right? Visual Studio has class diagrams. If you didn't install, you may want to install class diagram. It might help you with your codes in this class. State machine and activity diagrams, those are more for logic. So these two are more for logic, and this one is more for structure. There's also like component diagram, but since our project is very small, we don't really need it. You also have like architecture, like different stuff for the structures, but we don't really need it because I don't want to make it too complicated. So a thing that you might want to consider is perhaps considering these two first, like whichever you're comfortable with, or even you can just outline it, right? What exactly you need to do? This means that you're breaking down the requirements. So break down requirements. This thing is not catching correctly. Okay, and then yeah, and the class diagrams are creating for based on your classes, right? So in general, if you break down the class diagram, so to determine different classes, you have to understand, you have to like break down the sentence structures. So in general, we have nouns, right? We also have verbs, right? Verbs are for actions. Actions imply operations or methods. or methods, right? And then for nouns, they can be a couple of things. You can determine them to be a class name, right? Or more specifically, they can be attributes, like different attributes in your design. And these attributes are more related with fields or properties, depending on how you see the picture. So basically, this is the way that you should follow, right? Try to break down. Let's say if I gave you like a sentence, right? Break it down, like probably reword it so that's easier for you to break it down. You determine the nouns, you determine the verbs. The nouns will be either the class or the attributes. The verbs will be the methods. And based on the verbs, right, you have to determine like how many arguments, how many parameters you need, and so forth. So these are the the basic diagrams that you can consider using. Okay, so any questions? Is everyone still there?
Yes.
I don't know, like if everyone is around because I don't see any. I don't hear anything.
Yes, Professor, we are here.
Yes, Professor.
We are here,
How do
Professor.
I know? Maybe I should ask everyone to show you camera. If you want to show, I don't know, no one. I think, yeah. You can show me your camera. Why not? It's not just my face. You're not going to be uploaded because if you show me your camera, I think if I use Zoom to record it, upload it, they'll show you your stuff. Yeah. Okay. So let's analyze it. We have a few things that we need to analyze. Basically, we have to identify our class, right? So so maybe someone can explain to me like what exactly is this project about? Because if you don't understand this project, then obviously you're not going to get the right codes. Everyone has used the ATM machine, right, before, right?
Yes.
So how does an so what are the requirements you think of? Anyone?
You need to have a thin.
What? Can hear you. Let me turn on my volume. What happened? So can someone explain to me what's the purpose of this project?
We are going to create a console application for ATM functionality, wherein we are going to focus for a couple of requirements like deposit, withdraw, and viewing the main screen, letting the user to provide input, and then seeing if the amount deposited is reflecting back in their account, and then performing a couple of validations for this around this functionalities.
Okay, so basically you have a console application. In the console application, you're going to authenticate, right? You first start with the authentication, right?
Right.
Yeah. So you start with authentication.
With the PIN number.
Yeah, and then the PIN number, and then you ask the user to yeah, then you validate it, right? If it's wrong, you're gonna ask again. If it's correct, you log in, right? Getting a balance, right? And then you ask the three menu selections, right? The four menu selections. You have a view my balance, right? You pull the balance from the bank, right? Withdraw, deposit, and exit, right? Okay, so in this case, let's write down all the nouns that you think can be deemed as classes, right? So right now, let's write down the nouns as classes. So we're looking for any kind of nouns that come up into your mind, and we're gonna write it down.
Homepage.
Huh?
Homepage or home window.
So that will be
the main screen, the login screen.
Okay, so let's call screen.
Okay.
Okay, now what other nouns?
Input.
Huh? Input, yeah, so keypad. What other nouns?
Deposit and withdraw.
Deposit, yeah. So deposit, withdraw, and what else? So I did mention a few nouns already, but
check your balance.
Check the available balance.
What?
View.
Check the available balance.
Balance? Is that what you say?
Yeah, check the available balance, like how much amount
balance, balance is just a number, right? Okay, so let's write balance. But where's the balance coming from?
You say the current account.
Comes from your account, right? And where does your account reside in? Where's your account? Yeah, bank, right?
We also need to give a language tab.
What else?
A language tab.
Language stuff. Wait, what did you say? I can't follow.
Cache.
Cache from where? Okay, so let's write cache, but what cache? Let me stop using underlining. Where's the cache coming from? From tree? Money tree? From the sky?
ATM dispenser.
Dispenser, right? Cache dispenser. Okay, so dispenser. Okay. And what else? Is that all? Let me just double check they have here. So remember that we're gonna treat everything as like classes, and then we can try to figure out whether they should be class or fields.
So isn't the dispenser and withdraw same?
Withdrawal and so what's withdrawal? What is withdrawal?
We enter an amount and
So what's the purpose? So in OOP, right, when you define a class, right, you always want to make sure the behavior of a class is a single behavior, just only have one behavior, like one responsibility. So what is that one responsibility of withdrawal?
It will check to see if the amount is there, if there is enough amount
Yeah,
to
so
withdraw.
basically just withdraw money, right? Correct? So does the withdrawal have anything to do with your ATM?
No.
It
With
doesn't
the
really have
account.
anything to do with the ATM. All it does is that it takes the money out from somewhere, right? So,
Correct.
so what is the purpose of a dispenser then?
To check if the money is present in the dispenser.
Well, you're, no, I mean, what's the purpose?
Give the money to the user.
Yeah, so dispenser is part of the ATM machine, right? It has a fixed amount of money, right? So that's the purpose of a dispenser. So their two are completely different. This one has nothing to do with your account. Withdrawal may have an object composition of your account, but it doesn't have to be it doesn't have to like have anything to do with a ATM machine. So that's something you have to make sure of. So in an object class designs, always ensure that it's responsibility. So you have to make sure the responsibility. So this is known as single responsibility.
so speaking in terms of program, withdraw would check how much cash we have in the account. But what will be the function of dispenser?
No. Listen. Withdrawal is not going to check anything in your account.
Okay.
Because if it does check something in your account, right, then 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 it does two things already. It withdraw. It also checks for money, right? So basically, what you want is that the account class can check for check balance, right? And then you have to like you have to you have to validate the balance in the withdrawal function. Then you can finally just take out the money, right? So there's a few ways of writing this code, but we'll get into that one later.
Do we need balance class separately when we already have account?
Huh?
Do we need balance class separately because we already have an
Well,
account class?
yes. That's why I said we're just writing all the terms, and notice I put lowercase balance.
Okay.
This one could be a field of an account. It doesn't have to be a class, right? Okay, so the other thing is how about a PIN number, right? We can have we can consider making this. So we're gonna write down all the nouns PIN, right? PIN could be a class. I guess it doesn't have to be a class, but we can check it. So this PIN number can be used to validate your PIN number, right? Or we can you can put it as a part of the account.
Account class. Right.
Yeah. And then so you have a bank database, balance inquiry. We have another one called balance inquiry. I can't even see it, and my shadow's in the way. Okay, so balance inquiry. Then you also have the deposit slot. And then deposit envelope as well. Then you have you also can have let's say some kind of transaction, right? And then you also have let's say the $20. So this cash could be like $20 cash, right? Increments. Okay. Okay. And then we also have another one, the ATM, right? ATM is the biggest thing, right? Everything here is an ATM, right? It's going to be part of your ATM. Okay, so let's look at these words, right? Which ones do you think can be classes, right? Which ones do you think are classes? I'm going to highlight with a red color.
Deposit.
Deposit, right? Yeah. So this one we're gonna make it into a class, right? And which what else?
Withdraw. Account.
Withdraw, right? Withdraw account, we can make it into and then what else?
Balance inquiry.
Balance inquiry. Yeah. So this one can be and then what else?
Dispenser.
Dispenser. This one. And then what else?
Screen.
Screen.
Keypad.
Keypad. And then what else? I have a couple of things. Yeah, two things. Which ones can be classes? Remember, classes are structures of something, so it doesn't have to have just like an operation or
Bank.
bank, right? And then what else?
Mm.
That's it?
Do we need ATM as a class?
Yeah,
Because
ATM,
all
right?
these things.
That's correct. So that's all the classes we're going to create, right? We have ATM, screen, keypad, deposit, withdrawal, account, bank, dispenser, and balance inquiry. Okay, so let's look at our a simplified class diagram or component diagram. Okay, so nouns. Okay, first thing is that withdraw action. Let's rewrite this one. I think we're gonna add an extra AL here. Yeah, I think withdraw. Okay, so when you look at ATM, right? So this is going to be, let's say this is our ATM, right? So ATM, so when you look at ATM, what should I have? Let me just erase this one. So what's going to be part of the ATM based on if you can actually look at the one note because I can't I can't show you two things at a time. I can only show you one big screen. So if you refer back to OneNote like this one, just tell me like what's going to be part of the ATM. So I'm going to write ATM in big print here. So, yeah, so ATM can have a screen, and they're not going to be like what's that called? They're not going to be like inheritance. We're looking for object composition, right? Anything that's object composition. How many screens can I have? Can I have 2 screens, 3 screens, 4 screens?
One.
One screen, right? So we're gonna write like this. This is sorry. We're gonna draw it, right? This is known as class diagram. But simplify. We're not doing a complete version yet. Yeah. So let's see if I can do it this way. Man, I can't even draw. Or maybe I can do a shape instead. See shape, I do it. I don't have anything that's useful. Okay. Maybe into shape. I don't know what's that thing for. Okay, so I'm gonna just draw like this way, right? And then this one goes for what did you say? Screen, right? And then
One
what
screen.
else? Yeah, what else?
One keypad.
Keypad.
One keypad, and then what else?
One cash dispenser.
Dispenser.
Yeah, dispense. Actually, do we have dispensers in our class?
Yes.
Yeah, we
we
do.
do. Okay, so we're gonna put dispenser as well, right? Um, so this is gonna be keypad, and then we have dispenser, right? So these are all going to be part of the ATM. And then what else?
Deposit.
Here, hold on. We are missing something here. Hold on. Yeah, we actually missed one more item here. Okay, and the ATM machine. What else do we need? When you try
Deposit.
to, yeah, you need to deposit slot, right? We're gonna just write slot. So this is gonna be a composition. So every one of them is gonna have only one. That's why I draw with a solid line, right? Solid boxes here. Okay. So let's look at the next page. I don't draw this in complete version because I wanted to make this bigger. That's why I like doing it on the board. And this is a lot easier on the board than just on the computer. Okay. Okay, so let's look at execution, right, for withdrawal. Tell me exactly what are you gonna try to execute. So let's identify the execution. So this is ATM class diagram. Oh man. Wait. Click. Let's even click here. Let me click here. I hate this stuff. This is this, right? Wait, is it even froze up? Oh, it's syncing. It's kind of slow. Okay, here we go. So, ATM class diagram. Then we're looking for execution, right? Withdrawal. So executing withdrawal. Okay, so when you try to execute a withdrawal, right, we're gonna start off with ATM. Oh, what's that pen? Oh, here. Okay, so we're gonna start with ATM. So we're gonna start with ATM, right? We're gonna assume that ATM has everything else here. What the heck? Why is this? Man, this is horrible. Okay, so let's try. Yeah. So ATM, right? So when you try to do a withdrawal, right? What exactly do you have to do?
Bank account and
Yeah. So you have to
withdraw.
get. So you basically have to like log in, right? So let's say you have to log in. So this one will have to be related to the bank account, right? So you can get it from the bank, right? So this one will have to be from the bank, right? Bank database, right? So you're gonna do some kind of transactions here, right? Validating your stuff, and then from the login, right? You're going to then you have to like let's say you have to withdraw, right? So when you try to withdraw, right, this will have to when you try to withdraw, right, this will have to connect to the withdrawal object, right? You have to like create a new instance of our withdrawal object, right? And then whereby this one, right, will pull the data, like we'll pull the data from a bank, we'll pull the data from the you have a screen, it will display on the screen, it will display on the keypad, and it will display on the it will withdraw, so it will actually use the dispenser as well, right? So it will use the dispenser screen. So basically this will connect to the screen, the keypad, and the dispenser. So this is actually the whole idea. So this is like an example of how would you withdraw, right? Okay, so now let's look at our attributes, right? We know that ATM class, right, has to have a screen, has to have like a dispenser. It also has to have like a slot and this keypad, right? These are the 4 different attributes related to the ATM machine, right? These are going to be fields of part of the ATM machine. Now, on this page, right, I'll be looking over the attributes. So, what are the attributes of these different elements? Let's say we're looking at which one do we want to go first? ATM, draw balance account. Okay, so let's look at attributes here, right? So tell us, tell me the attributes.
Account number.
Huh?
Account number, PIN.
Where? Which class?
For the bank or the account class. To log in, we need the authentication details, which are the account number and the PIN number, which would be into account or the bank.
Hold on. Let's go back here, right? This one, right? Yeah, let's go back here and then let's look at all the classes again. So make sure you only have follow these classes. If you try to add new classes, then you have to ask yourself, is it necessary or can you consolidate into another class? So when you so I don't see anything about login here. Login is actually an action or a method. So when you try to so for the let's look at account first. So in the account, right? So in the account, right? What attributes do you need?
Account number.
Account number, right? Number, right? And then what else?
ATM PIN number.
Yeah, we probably need some kind of PIN number, but this one has to be hidden, right? You have to encapsulate it. Okay. And then what else do you need?
Balance.
Yeah, you need a balance. The book actually has total balance and available balance. Yeah, I'm not sure what's the difference. Available balance. I guess it takes like a few days for it to clear, but let's just make it simpler. Just have one balance. I don't know why do we need available balance. Okay, then what else? What other stuff do we need?
account type, whether if it is a savings account or
Which one?
account type.
Is it necessary? Well, actually, you know what? I don't think you can have a debit card for your savings account, can you?
We can have it.
Yeah, but I don't think it's relevant because so that actually is an extra requirement that's not relevant to this problem because the problem only asks to create an ATM machine. So whether your account is a savings account, checking account, it doesn't really matter. So what else do we need? Like this one is actually okay. So we're finished with account. What other classes can you think of? Okay, so we have let's say we have dispenser, right? So what's going to be part of the dispenser?
Deposit or withdrawal of cash.
Yeah, how much cash, right? So
Yeah.
this could be you can say how much cash, right? So we can have cash, right? The books count. I don't know what's count, but I guess it's the reason is that dispenser can only have like $20 bills, right? So we're gonna write count, right? So count of a number of $20 bills. So this is gonna be $20 bill. Okay, let's leave that alone. Okay, so that's basically it. They have a deposit, but I said we're gonna leave that alone because we may do a little bit differently from the book. The book takes an account number, but I don't really think that we need an account number. We can actually just link it to the actual account. So I'm gonna leave that alone. Okay, so let's look at an activity diagram.
Professor, one doubt. In the dispenser, like, do we have to check how much cash is remaining in the ATM machine? Like, suppose.
Oh yeah,
will there be any limit?
so we can have we can predefine as 500. But yeah, it would check. But this is all of the stuff are attributes. They're not operations. You can have an operation here to check how much money does it have. Like is it 500 times 20, which is like $10,000. So how much money is left, right? You can check it that way, but of course count is going to be is going to be like encapsulated because if you expose the count, right, people can change this number, and also if you just make this public property, right, count, and then maybe you do it like private seller. The problem is that with that method is that the count is set to an arbitrary number, and someone from outside doesn't know what does it mean by count. It could be count of $100 bills or single dollar bill. So no one has any idea what does this count mean, except for the class itself. That's why we wanted to encapsulate this number, and in order to use this number, we're going to pass into a method that validates how much money is left and also subtracting from this count. So questions? The first thing is to understand your data attributes. Okay, so let's look at a simplest case, right? So obviously, if I ask you to write this code without using classes, you probably know how to write it. So let's say we're doing a logic or activity diagram for balance inquiry. So how would you write this code? So we start with this, right, and then we move down, right. So first you have to log in, right. Then you have to get balance from bank. And basically you're just gonna display and then exit. Okay, so this is the exact idea how this is gonna work. I hope it's clean. I don't know if you can read my handwriting. This thing is like really hard to write. I bought used. This is infrared sensors. It's really hard to write on here. So get balance from bank. Okay. So we're gonna have a start. Then we log in. Right. So you have a start. Then you log in. Then get balance from bank and display and then end. So this is the whole idea of the balance inquiry. Now, how would you so which objects are related here? What are the possible related objects in this case? So when you want to log in, right? Before you log in, what objects do you need to use?
Screen and keypad.
Account.
So you basically need to do a screen and keypad, right? Right. So you're gonna print something on the screen, then use the keypad for the user to input. And how about the process of logging in?
Account.
How do you get the account? So the keypad, by the way, will enter your account number, and then you will also enter your PIN. So the question is, how do you log in?
Can we perform a validation there?
Yeah, but which objects do you use? Yeah, which object? Which class?
Account class.
No. Where's account?
Bank.
Okay, bank.
Bank. You need a bank, right? You cannot just pull the account from nowhere, right?
Mhm.
It has to be from the bank. So you obviously you need to pull it from the bank, right? And from the bank, right? It will get the account, right? But after you validate with your number, right, and PIN, right? After you validate your PIN number and your PIN and also a number, right? Then it can get your account, right? So once you have your account, you're logged in, correct? Now, getting the balance, right? This one, instead of just getting the balance from here directly, we're not doing that way. We're doing a little bit differently, because the idea for this project is to help you understand the abstraction and polymorphism. We don't want to get from the account balance. That's not what we're gonna get. We're gonna use a balance inquiry class, right? Instead. So whereby this one is going to relate to the account, right? You're going to have the account related into the balance inquiry class. So these two are going to be strongly related. These two, account and balance inquiry. And then, so basically balance inquiry is going to get the account. Then you're going to have some kind of general function here. I don't know why is this. Oh, gosh. Exit. a crappy software. Okay, so balance inquiry is gonna connect to the account, pulling the balance from the account. Then afterwards, you're gonna have some kind of general function, some kind of common function. The reason I say common is because this piece is because that piece, right, can be replaced by anything. It doesn't have to be getting a balance. This is going to be replaced by you can replace with a deposit. You can replace with a withdrawal. You can also replace with balance, right? So inquiry, right? So you have deposit, withdrawal, or balance inquiry. 3 different things. All you need to do is to replace this this box. So in general, we're going to create something called abstract class here. So this is going to be an abstraction here. That's what it means by abstraction. An abstraction will allow you to replace a functionality of a particular block as long as they share the same characteristics in terms of how you interact with that class. So we're going to use a concept abstraction for this. So this is going to be based on your menu selection: 1 deposit, 2 for withdrawal, or maybe the other way around: 1 for balance, 2 for withdrawal, 3 for deposit, whatever it is. Based on your selection, it's gonna call create an appropriate object, passing your the appropriate account information in here, and then it's gonna call some kind of common functionality, right? Then we're gonna get to a display. So what classes are related in display? How do you display something?
Using screen.
Huh?
Screen.
Screen, right? So this is essentially going to be a screen. So that's the whole idea of this project, and this part is going to be part of your ATM, right? Questions? Okay, they kind of expand a little bit in detail. What time is it? It's 3:10.
Professor, I have a question.
Yeah, sure.
So in the account class, the only operation which we are going to do is, getting the balance. Why do we need a separate class for balance inquiry?
Well, I explained, right? Why?
Just to replace it in terms of using abstraction rather than calling.
Okay, so let's say so here, right? This block. We're looking at this block, right?
Right.
So basically, just think about you got your program correctly, right? You have deposit, withdrawal, and balance inquiry, right? You have these 3 things, right? Right. And then so is the login going to be the same for deposit, withdrawal, and balance inquiry? Is it going to be the same?
Yes.
Yeah, it should be the same. Display can also be the same, right? Can also be the same depending on how you pass the data. This can also be the same because it's just passing to a screen, right? Now, what's going to be different?
Only the operation.
This one, right? This is going to be different, right?
Yeah.
So you have balance inquiry or deposit or withdrawal, right? So instead of writing this stuff over again, right, and instead of doing like different things, calling like different functions or having like a bunch of if statements here, right? We can create like an appropriate object. We can create the appropriate object. Let's say you have something called so basically, you're going to create an appropriate object based on your menu selection. If you choose a deposit, you create a deposit object. If you choose a withdrawal, you create a withdrawal object. If you choose a balance inquiry, you create a balance inquiry object, right? And then you're going to call like the logic directly. So basically, you have some kind of class here, right? You have some kind of class here, and then inside the class you have some method. Let's say execute, right? And then here you're gonna just simply execute this method, right? You're gonna simply call this method, and this method contains either you're gonna deposit, or you're gonna withdraw, or you're gonna balance. You're gonna inquire balance. So this in generalization, we can call it a transaction. So we're going to generalize all three segments here: withdraw, deposit, and balance inquiry. They're all transactions. Deposit is a transaction. Withdraw is a transaction. Balance inquiry is a transaction. Therefore, these three, like deposit can extend transaction, withdrawal can extend transaction, balance inquiry can also too. Questions? And the goal is to help you understand abstraction and the polymorphism and encoding. That's why even though this is probably an easy job, right? All you have to do is get it from the account and then print the account balance. But I think 3 is better than 2 classes. The book thinks so too, and it helps understand better with this new concept. Okay, any questions? Any questions? Which one is this one? No, this is attributes. No question, everyone understands? Is the school doing anything for the Zoom privacy concerns? Yeah, I read about privacy on Zoom, but I'm not sure. So no questions? Okay. Let's look at account again. Right, so I'm going to look at account. So I'm going to draw a line here. Let's draw a line, blue line. Okay, so under the blue line, I'm going to add some operations. So which operation do you think that your account should have?
Authentication.
Authentication, right? Authenticate. Yeah, authenticate. I'll just call it like authenticate. Because normally when we create method names, we wanted to make sure that it's a verb, it's an action. And then here we probably want to also pass something else here. So we probably want to pass a pen here, right? Trying to figure out which color looks good. Yeah, pen. Okay, so we pass maybe we pass a pen here. Then the other thing is what else do we need here?
Account number.
Well, we already have account number. This is actually plus minus, right? Minus and minus. So what else do we need? Okay, let me just say that don't you need to put money into your account or not?
Initial deposit.
Yeah, so you're gonna put they call like debit and credit. This is these two are functions. They have nothing to do with the nothing to do with like deposit and withdrawal. These are just two functions, and actually, you know what? We're gonna add some arguments here. So amount and also amount here. Okay. And then let's also look at a cash dispenser. What attributes do we need? Not what operations or methods do we need here? So you're still worried about a score? Probably like later this week. So what's going to be inside the cash dispenser?
Validation for the cache.
Yeah, validation. So you call like is cash available? Is sufficient? I guess it's available, right? Did I spell right? Available. Yeah. So we have one function. This one. Do we need any arguments? Or no?
Like the input amount.
Which one?
Input amount.
Yeah, you need some kind of check, just checking this thing, right? So you're gonna check an amount here. This amount, I'm not sure how you want to do it, but we're gonna see if we can make it better. Then we have I'm not sure if it's gonna be amount. It could be something else. We can try to see is there a better way of doing it. Because some of the book designs I may not like, because I'm sure it can be improved significantly. And this is going to be dispense cash is going to have an amount as well. Notice that these are two different units. One is amount. See, one is amount. Then we have a count here, right? So these are two different units. So I'm not sure if like if we're keeping the amount, or maybe we do it a little bit differently. Then we have a few other things. Let's look at a bank database. Let's look at a bank. Bank, okay. So let's look at what's in the bank database or bank.
Account number.
Huh?
Account.
Account, or is it plural or singular?
Accounts.
Yeah.
Accounts.
Yeah, it has to be plural. And when it's plural, which what data type do you think it should be?
Reference.
Plural is a collection, right? We're gonna start a little bit on the collection, but we're gonna use the ones that you already know. Nothing else new.
Array.
We're not gonna use arrays. I don't really like it that much. So we're gonna use something else, something that is gonna be more dynamic size.
List.
List, right? Okay, so let's look at lists. So we're gonna write accounts, right? Plural. So this is gonna have accounts, and this is gonna be list colon. This one means this has a type of list, and we're gonna use account. So something you already know, but we can change that to a much better one later on. Okay, and then And then what else? What else do we need? Do you know about database? Come on, no one's talking. I don't understand it. You know, otherwise it's just going to be a boring class. Should I unmute everyone and listen to some background videos or? So what's in the bank? So we can make the bank more complicated. Like so this is gonna be our bank, right? So let's say we can do
Transaction.
yeah. So they have a balance. Bank may have a balance, right? Like how much money they have. So I'm not sure if we're gonna keep it, but we'll see. And these are actually gonna be all like private. Okay, so once we're done with this one, right, we can write methods, right? So one of them is we can have so what are the different operations here?
Withdraw and deposit.
No. I probably won't follow the book because I like the database better. So what's part of the database? What can you do with a database or table? No clue. Who has taken database class?
User account table.
Yes, so we have a council. We're gonna treat this one as a table, right? Yeah, that could be a tree as a table list because a table is has a lot of records, and that's exactly what list does. And then we also have columns which are represented as field names. Those are so that's representative. But the thing is about account bank, right? What can you do with a database? Remember that this is going to be private, right? How do you access the account? How do you access the account?
Login.
Huh?
Login.
Routing? What?
Login. No.
Yeah. It's your volume is a little bit too big, too loud.
Okay. I'm sorry. We access the account by logging in.
By writing? By
Login.
oh, login, right? Login. Yes. Yeah. So actually, a more general term. I like this term better. Fetch. Account or get account, but fetch account we will need what do we need here?
Property.
Huh? I know, but which arguments?
Account.
When you fetch an account, what do you want?
Account number.
Yeah, you need a account number. That's it.
Pass the list.
We can we may also can pass a password as well. So this one forces you to when you try to pull an account, right? It kind of forces you to pass a PIN as well for security reasons. Okay, and then you can also check the PIN number whether it's correct. You can also check as well, right? So everything will be the same. What else? Okay, so the book has get total balance, right? So we can have total balance. I don't know what's available balance and total balance. It's kind of weird. So we can get balance, right? Actually, you know what? I don't think you need it. I don't know what's that one for. Oh, actually, let me think. No, you don't really need it because so I don't know what's this one for. So I have to look at it. Yeah, we don't need this one. And what else can a database do? Does anyone remember the four letter acronyms?
Yeah, create, update, delete, and
So which one do we are we looking for? Which letter? So we need to have a way to somehow update the account, right? Uh, And of course, if you're passing as a reference, right? If you're fetching an account and then that returns a reference, then it's going to automatically update the bank, the bank account. But the other thing is that we can also like create a new instance of the account, so that it's not going to mess up the database when you try to modify the object. So I think the best way is to clone it and return it and then update it later on. So we're gonna like have an update account here as well. So we're gonna just update, just follow like whatever we're doing in database update account. So this way we will pass the object. So this will be an object that you're passing and update the account. So that's a bank. We're following like exactly what a database does. Uh, by the way, this one, right, is going to be more of a predefined list. So we're going to like hard code all the different account info here. So that you create, let's say, 5 different accounts with 5 different pins, 5 different account numbers, and to get the fetch account. So how would you do? How would you write the codes for fetch account?
We'll iterate through the list and then check if the pin number matches with the ones in the list.
But first thing is that you have to iterate through all the elements, right?
Yeah.
All
For each.
you have to for each or for loop of the account list. Then for each account object, you validate the account number as well as and the PIN number. So you can do that, and to validate the PIN number, right? This PIN number, right? You don't validate directly in the bank, right? Where do you validate the PIN number?
User input.
No, the function you're calling is going to be here. You're going to use this one to validate your PIN number. You're not going to like because this one you're not going to be able to get the PIN number, right? In
Right.
order to get validate the PIN number, you authenticate the PIN number, right? You call this function, and then pass the PIN number, and then try to see if that's the correct PIN number. Instead of doing like account.pin, which is impossible, that's an encapsulated field, equals to pin. You don't do it that you never do it that way. And with security and one-way hash example are like MD5, SHA-1, SHA-256, whatever. So with these hash, you cannot, when you pull the pin number, right? You get like some garbled some garbled string, and if you try to compare, you don't know like how to compare that string. So we're gonna, so most of the time is that you for this encryption, you encapsulate all the encryption and just get let's say get the password from outside, and then do like some kind of logic to validate a password or PIN number, then return true or false. So that's a technique that I need like everyone should know. And when you go into the industry. Okay, 3:30. Okay, let's look at the remaining classes. So we have this is the basic class diagram. We did no, actually this one. We did account, we did bank, we did dispenser. We also did I think that's it. Account, bank, dispenser. Yeah. Let's look at a screen class, right? So let's look at a screen class. So in a screen class, what do you need here? Oh shoot, what's going on with my iPad? So in the screen class, what exactly do you need?
A welcome message and prompt for entering account number and PIN number.
No, screen doesn't ask you to enter anything. Do you enter in front of your monitor?
Then the display options.
Which ones?
To select an option.
To select an option. No, selecting has nothing to do with the screen, right? So what's the purpose of a screen? What's the behavior?
Display the data.
Display, right? Yeah, so all you have to, not just the data, but just simply display any kind of messages you want, whether it's your balance or anything else. So we're gonna just display message, and this is actually synonymous to console.writeLine, correct? So let me ask you this: why are we? Why can't we? Why don't we want to like pass in console.writeLine directly? Why? Why not?
We can pass different messages to this and reuse it for different purposes.
Examples?
Withdraw, get balance.
So why don't we want to use this one? Of course, display message can implement console.writeLine, but why don't we see why are we writing a separate method that calls the console.writeLine, whereas we could have just called this one instead?
Because we have different accounts.
One certain thing
What
at a
happened?
time. Like, we need it only to display. Like suppose if we withdraw some cash and we need to display only that information. So
No, but you can do that with a console.writeLine. You can also display the information. But why are we not using console.writeLine?
If you wanted to reuse that particular value,
Reuse which value?
like forget balance. If you wanted to use the balance
No,
amount.
but screen array has nothing to do with the balance or your account or anything else. All it does is to display a message. So the question remains: why are we not using console.writeLine? No one. I'm only hearing like 2 people, 3 people talking. We have like I don't know how many people we have here, but we have a lot more than 2, 3 people here. If you don't answer it, I can let you go. No clue? So let me ask you this. The ATM machine, right? Initially, you said you want to create a console application, right? Can it be a GUI? Can it be a web application? Or can it be just a standard machine? Can it? Yes or no? It sure can, right? It can be a console application. It can be console application. It can be a GUI application, right? If you stick to console.write, if you stick to console.writeline, right, that means that your design only works for console application, not for anything else, right? We want to make this as versatile as possible. We want to make sure that our ATM machine can be implemented differently, can be implemented whether it's a console, GUI, or web application. It doesn't really matter. So the way that we have it is that we can create like different interfaces of screen, right? We can create one interface of screen, and we have a console screen that implements the abstract class or interface of the screen to display a message, right? We can do that, right? And so console screen was simply called a console.writeline, whereas a form, you may have to pass like different form objects in there, and then it will send a message to a label or to something else. And then for a web application, you can send it to let's say to what is it to some kind of element. You can send it to like an element in web application. Doesn't matter, right? As long as you're calling a display message. If you have a console screen, it's going to print something on the screen. If you have a web screen, it's going to print something on the web. If you have a form screen, it's going to print on a Windows form. That's what I'm trying to say. Screen. The reason that we do it this way is so that your design can be later on extended to other interfaces, other like GUI or web interface. In fact, I think I did this one before. I did it with a console, then I switched it to GUI without any problem. As long as I like modify my the screen and keypad codes. And probably you want to use like an iScreen. Yeah, probably you want to use an interface instead. So this is all the considerations you have to make, right? And when you have an interface, it means that in the Windows form, I believe I use iScreen, and then and then just print something to a label. But it still calls a display message. Okay, then we have a keypad, right? What's in the keypad?
Input, string or
Input. What kind of input? Are you accepting?
integer.
Yeah, so some kind of integer, right? So keypad only accepts integers, right? Let me just see how the book does it. If I need to like rename it, I'll do that. So that won't be too much off from the book. Come on, where's keypad? Screen. Oh, they don't have a keypad here. Wait, I don't see keypad. Oh, here, operations of class keypad. Okay, so keypad, they have some kind of get input, right? So they have, this is going to be return an integer, right? Okay, so you have a get input. It's going to return some kind of integer, right? Uh, so 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 this one essentially means people someone's going to input some numbers, right? So we can write input, right? And then you have something here. You can probably specify how many digits do you want. Like if you want one digit, then it's gonna input just one digit. Like this could be like a number of digits. Then this returns an integer. Yeah. So you may want to like specify the number of digits, right? That are allowed in the input. Then it's going to allow it. So it really depends how you want to implement it. But for this one, essentially we can do a couple of things if you want to make it fancy in the console app, right? Normally we can do like using like a read line, right? Number of digits. But the problem with read line is that it accepts everything, right? It accepts not just numbers, but also characters, right? So in order for us to simulate how keypad works, do you remember like which console functions would we use? Hmm.
Read line and
Read line, write line.
If you use readline, that sounds right because readline accepts any characters. That's why I said right. But we only wanted to accept just numbers.
Two string.
Which one?
Two
Toostring?
string.
No, toostring. Console is a static class, right? It's a class. If you there's no such thing as class toostring.
Read key.
Yeah, read key, right? Why? Well, what does it do? So what does the read key do?
It will read the character entered in the console,
Yeah.
and then maybe we can convert it to the type.
Yeah, but you can also validate, right? You can verify if it's
Right.
a digit. If it's not, just ignore it. So
Right.
what this one means is that you need some kind of loop, right? And you're gonna loop it through this thing, right? Number of digits, right? So this way you can ensure that this always has this number of digits. For example, pin number is 4 digits. It's always going to be 4 digits. So you're gonna loop 4 times, and that's why we probably want to specify the number of digits into this interface.
So this is going to be the way that we are going to handle whatever the input is. Either it can be an
Yes,
pin
instead
number,
of
or it is going to be
yeah,
selection.
so instead of calling this directly, you're gonna call this function, whereby this function is gonna have this logic. You loop through this number of digits times, and then you do a read key, and until you enter like this n number of digits. Yeah. Okay, so let's look at 3 other classes, right? We have 3 other classes plus new page. So basically, we have balance inquiry. This one we talked about before, right? And then we have withdrawal. And then we have deposit. Okay. We have 3 different classes. And if you look at balance inquiry, so all of them are going to have an account, right? So all of them are going to have account, right? Obviously. And this account again, you're pulling from the bank database, right? So you need a constructor. So this is what we call it as composition, right? The account is a composition. And the other term is also called delegation, which means that the object is delegated to this instance. But when you delegate it, you have to pass this account in as an argument into the constructor, thereby initializing this account, the account field. Okay, and then for withdrawal, right? We can also have another one, right?
Amount.
Yeah. Okay, so you may ask me, why am I putting amount here? Oh crap. Man, I wish it's all those. Oh, let me just delete this one. Okay, so we may put an amount here. Okay, so you may ask me, why am I putting this one? But this one doesn't really have an account. So this one doesn't have an account, right? The balance inquiry. Because we don't really need an account amount. So these two fields, right? These man, I need to use a different color. Let's use green. So these two fields, and this one field are all initialized via the constructor. Initialize via a constructor. So you're gonna initialize all these three fields via a constructor. The account is gonna be you're gonna log in initially, fetching an account from the database based on your credentials. Then after you get your credentials, you'll be able to pass that account fetched into creating new instance. So you're basically going to create a new instance of balance inquiry, a new instance of withdrawal, and a new instance of deposit. Now the question is that we have this amount here, right? What are we going to do with the amount? So the amount actually we can actually see that in the moment, that you have to somehow let the user enter the amount so long as the user are in deposit or withdrawal mode. And finally, after everything is done, right, you have execute, right? So let me just write in blue letters. So you're gonna have blue letters. This one is all the functions, right? Right. So do you see any repetitions here?
Execute.
Yeah, so basically a lot of things are repeated, right? So one of the examples, account are repeated. This is also repeated, right? This is also repeated, as well as all the stuff here, right? Okay, so we have a few things that are all repeated, correct? So in other words, when you do a commonality analysis, right? So these are commonality. Let's say analysis. We're gonna try to see if we can make them into a inherited object, and actually we can, because balance inquiry, withdrawal and deposit, right? Balance inquiry, withdrawal, and deposit are all part of a transaction, right? So they are all transactions, which means that we can have define a transaction here as a class that will have account and also execute, right? Oh man. So you can have account and execute here. So and then under the account, right, you can have 3 different classes, right? So one class can be balance inquiry. The other class can be withdrawal. And then the other class can be deposit, right? Am I doing it right? I just want to make sure I'm writing in the same order. Yeah, deposit. Okay, and then this one, let's put in rainbow colors. Okay, so we have 3 different classes, and this transaction can have these like the field. This could be this one in order for the balance inquiry. So in order for a balance inquiry, withdraw and deposit to access the account, right? This one obviously has to be a protected. I'll put a hashtag here that indicates it's a protected property, whereby you can initialize the account in the transaction class, but you also have to initialize it here directly from the balance inquiry. And this one is going to be an abstract class, right? So this is going to be an abstract. So you're going to write this as abstract. What time is it? Okay, it's already 3:50. I know the book has a lot of words here. Yeah. So does everyone understand what are we trying to accomplish here? Like you have an ATM machine, right? The ATM is going to try to log you in, get the account, right? That's going to be calling to a database, to the bank database. Then after you have that, then you're going to go. The ATM is going to go through some kind of menu for your selection, and based on the menu selection, it's going to create different objects. But for withdrawal and deposit, it will further ask you for for two more fields. And we have actually I actually have a different way of approaching that problem. So that it makes it more uniform on the during the withdrawal process, because sometimes you don't want it to have too much stuff in the too much stuff in the main class. Uh, Yeah, and then after you execute it, then it's gonna have some kind of message that you can display. That the execute is probably gonna give you some kind of message that you can display on in your using your screen class to display stuff. And then you also have to figure out about cash dispensing, whether how are you gonna dispense your cash and so forth. So we can look at different ways of doing this problem. So any other questions?
Professor, is it possible to do this project on groups, like for twice, for 2 people?
Groups? What do you mean?
So that, like, it's a project, right? So we can do it in like 2 people.
For the test?
Yes, for a test.
No.
Like it's
No
for a project.
No.
Okay. Okay.
Because the problem last semester I did a project, and only one person did the work, and the other 2 people don't do anything. Like usually that's what happened. Then we have groups, 2 people doing the work, one person did absolutely nothing. If you have 2 people group, those 2 people are gonna collaborate, and then they think it's gonna work, but But
Like some creative idea means more attractive design and will be created like code and all that. And if we can discuss in the group, so
remember that this class, I'm not training you to create elegant codes. That's not my purpose. The purpose is for you to get exposed to different techniques and coding. If you do it in groups, then you're gonna be kind of like brainwashed by your other teammate. That's why I'm also I'm also available. The TA is also gonna be available. Is he logged in? See, I haven't even checked who's logged in. But don't worry about it because I have all the logs in my chats, like who's logging in. Yep, so Boris is here. So if you have questions, I think you should contact any one of us and we can make suggestions on your designs and stuff. But we're gonna look at the designs first. Because
okay.
I also want the designs to be good, but the goal is to get the codes because our course is called C Sharp. And and if I give you the design, sometimes you're just writing the codes and without even thinking too much. I also want you to think a little bit when you design it and try and maybe I'll also add like a requirement that after 3 hours or after like maybe an hour or 2 hours we have to like follow up and see how it goes. Because it's also like the first time I'm doing this in terms of giving you a test, in terms of giving you a project that I'm giving you about like this little time to complete at 6 hours.
Yes. Okay.
Yeah, but I'm not sure how that works out, so I'll see what's going to happen.
Yeah, because this is the first time for us too, so so I'm
Yeah, I
thinking
don't
about
know.
this. Yeah. Okay, no problem.
But if you want homework assignment, I can give you another one, and also for this one, right? By next week, implement whatever we talk about on OneNote. Like just write the codes that you think what's how we're. I know we did not finish talking about all the designs, like how we're gonna dispense the cache, but let's just try to implement one step at a time. Like just implement these basic functionality, and then later on you'll see like some problems. Then we can discuss. And
Okay.
I'd rather have everyone discuss in this class instead of just having like a couple of people saying something after like a minute of wait, because this way everyone would know like what's expected, because in an OOP designs uh, it's more about teamwork than working alone. But for our class, I notice like students sometimes when you collaborate, they don't really understand the problem. And they just assume your teammate actually understands it, but both of you don't really understand at all. And I prefer you follow up with me. I think the TA should be okay about your designs first. But I try to make the tests shorter. Like it won't be as big as this one. This is obviously too big for a test, but it will be shorter, maybe up to 5 different types, like abstract class or interfaces, and a couple of derived classes. Then we have maybe one main class, so that's 5 class. So basically that's what I'm looking for, 5 classes. And I'll give you a lot of hints during the design process. So design process, I'm not going to grade too harshly. The one that I will be graded is going to be more of your codes, the final output. The design is going to help you learn for this process, but the codes will be more of yeah. Let's see. Hold on. Let me just double check. So we have a test on Saturday, right? I need my keyboard. Word. Okay, let me just double check our syllabus. Let's take taking a long time. You know what? Let me just share the other screen. Okay, I don't know where is that. It's gone. Here we go. All right. So I did put on Saturday 4:25. And then we have yeah, collections. I'll probably just talk about dictionaries. And then we probably can talk a little bit more on 420 as well, just introducing you to collections. But I think with this stuff, everyone should be able to get this project working, and then I'll add some shorter problems as in the meantime to help you understand OOP. Any other questions? And I hope everyone will be safe.
Yeah, Professor.
Yeah, I hope so. Like, yeah, just don't get caught with I don't know, whatever it is. Okay, I think that's it. I'll see like about the homework assignment. Just gonna be like one problem. I think one or two problems just help you get started with OOP, and here it's more about like abstraction and polymorphism. Those are the two things that are going to be harder. Inheritance is just the is keyword. If you cannot form that sentence, then it's obviously wrong. Most people can get that part correctly, but when it comes down to designing a different abstraction or using the abstract class, people are going to be a little bit more difficult with that part. So we'll see how that goes. I don't even know where's my stuff here. Is it on the other screen? Oh, here we go. Okay, so let's end the meeting. Thank you for attending.
Thank you, Professor.
Do we have everyone here?
Yeah.
Yes.
I don't think so.
16 people are here, participants.
How many people? 15? We have 15 people, so one person is missing, right?
16. Oh yeah, 15 including.
1, 2, 3, 4. No, yeah, we have so 2 people are missing. Yeah, so I actually saw there are the 2 that did not submit the survey. So I'm wondering what's happening. I'm just gonna follow up with them. Yeah, thank you so much. Okay, goodbye.
Thank you, Professor.
Bye.
Sure.
Bye.
Take care.
Oh.
And meeting for all.